everyone, this is Mr. Faribaugh, and in this video I'll be teaching you about scientific notation. So when is scientific notation necessary? It generally tends to be used for numbers that are either very large or very small. Scientific notation is a way of abbreviating a number so that you don't have to write all of those zeros out on your paper. When you can simplify a number and avoid writing all of those zeros, then scientific notation is a great method. Another important application of scientific notation is it will show you the number of significant figures in a measurement or calculation. Now, if you're watching this video and you don't know what significant figures are, don't worry. You can check out a video that I will post that will explain all about significant figures. But in this video, we're focusing on converting numbers between regular notation and scientific notation. So what does a number look like in proper scientific notation? It has a coefficient followed by times 10 to the a particular power, an exponent, and this coefficient must satisfy the condition of being greater than or equal to 1 and less than 10. If your coefficient is not satisfying this condition, if it's either too large or too small, then you will not have it properly formatted in scientific notation. As far as the exponent, it generally tends to be positive or negative. Now the exponent could be 0, but 10 to the 0 is equal to 1, and that's not a very interesting example. So let's decide whether or not the exponent is going to be positive or negative. If your number is large, say more than 10, then the exponent will be positive. If the number is small, say less than 1, then the exponent will be negative. And what I find is that it's much easier to think of these numbers as being either more than 10 or less than 1 to help you understand the exponents. Trying to memorize shifting to the left or shifting to the right, it could be confusing. So just remember, more than 10, positive exponent, less than 1, negative exponent. In these examples, you're going to turn a number from regular notation into scientific notation. Here's how we do it. We start off with a coefficient that is between 1 and 10, so in this case 2.7, and then we have to make a positive exponent because this number is larger than 10. Now what should the exponent be? If we count the number of decimal places that we must move the decimal to get to the end of the number, we discovered that we're moving the decimal place 6 spots over to the right. So 2.7 times 10 to the 6 would be the proper way to represent this number. Here we have a small number which is less than 1, so our exponent will be negative. And you're going to write this as 8.06 times 10 to the negative 3, because you have to move the decimal back 3 spots to the left. 8.06 times 10 to the negative 3 is the correct way to do that. Now we have a number which should be written as 1.5 times 10 to the negative something, and that something is negative 4, because you have to move the decimal back 4 places to the left. 1.5 times 10 to the negative 4. And then finally, 90,400 should be written as 9.04 times 10 to the, what power will it be? Positive 4. You're moving the decimal over 4 places, but now it is a positive number because the number is greater than 10. Now in these 4 examples, you can see when you have a positive exponent, it's more than 10, and a negative exponent, it's less than 1. Okay, now watch out for some common mistakes that students may make when converting a number into scientific notation. 125,000, a person might decide to write 125 times 10 to the 3. This is incorrect because the coefficient is too large. It must fall between 1 and 10. Well, 1.25 times 10 to the negative 5 might seem like a better answer, but this is still incorrect because the exponent should be positive, not negative. 125,000 should be written as 1.25 times 10 to the 5th power. Now I would like you to have some chance to practice. So at this point, you should pause the video, write these 6 numbers down on your paper, and convert them into proper scientific notation. Then, once you are ready to check your answers, you can press play. Okay, let's see how you did. The first answer is 5.02 times 10 to the 7th power. Now we have 3.00 times 10 to the negative 3rd power. The next one is 3 times 10 to the 3rd power. And if you're wondering about why I decided to write 3.00 in the second example, and yet just the number 3 in the third example, this goes back to a knowledge of significant figures. So why those final 2 zeros in the second example are significant, and yet the 3 zeros in the third example were dropped as not being significant, you'll understand more when you watch the tutorial video on significant figures. Okay, next answer should be 1.78 times 10 to the 8th power. Then we have 9.40, and I'm adding the 0 as a significant digit. 9.40 times 10 to the negative 5th power. And finally, 5.0 times 10 to the negative 1st power. Now, for any of these problems, if you got them incorrect, hopefully you understand what mistakes you made. All of the coefficients fall between 1 and 10. And for all numbers that are greater than 10, I used a positive exponent. And for all numbers that were less than 1, I used a negative exponent. Well, if you feel comfortable converting into scientific notation, then let's give you a chance to convert the other way around. So again, I would suggest that you pause the video and write down these 6 numbers on your paper, and after you've converted them into regular notation, you can press play to check your answers. Okay, let's see how you did. This first one should be a number that is large, more than 10. We're talking about moving the decimal to the right 5 places. So it becomes 803,000 for your answer. The next example should be moving the decimal to the left to make it smaller, less than 1. And the final answer is 0.000450. In our third example, we have to move the decimal point 6 places to the right to make it a larger number. 9,270,000 is correct. In our next example, we have 4 significant digits, which I do not get rid of. When I write this in regular notation, I still keep all 4 significant digits. So if you thought the answer was 300, it's actually supposed to be 300.0. Again, the issue of significant figures will be discussed in more detail. Our next example is going to be a smaller number as we move the decimal to the left 6 places. And that is our answer. And finally, we have a number that becomes smaller as we move the decimal to the left 2 places. The answer is 0.0210. Well, after having a chance to practice, hopefully you understand scientific notation much better now. If you still have questions, come see me in my classroom. And hopefully you found this video helpful. Thanks for watching.